Alright, now, this is a weird process. I'll be honest, this one is a weird process. But it's not too bad. You see how when we figured out, alright, our u is 5x plus 1, but our du didn't get us anything that we needed. Because there's still that x there that's not helping us at all. Now, there is a process in which we want to go about doing this. I'm going to take this guy and move it over here. U is equal to 5x plus 1. And it's kind of like a double u substitution. I'm going to subtract 1 from both sides. U minus 1 is equal to 5x. Divide that whole thing by 5. And so now I have x is equal to u minus 1 divided by 5. We might need some extra room here in a second. Now, first off, everybody kind of see this? Now, good question. Why did I do that? Because when I took the derivative of u, this guy was all by itself, and there was nothing. That was not in the. Yeah, well, it was not there. The x was gone. The x when we took the derivative went away, so there's nothing left to do with that x. And if I did all my u substitution, there'd be u's, and then there's an x there. So in order to change all my x's into u's, that's the whole idea with u substitution, is to change and get rid of all the x's and put them in terms of u's. If there's that extra x that's sitting outside like this, then what I need to do is I need to come up with, all right, x is equal to u minus 1 over 5. Now, what I can do is I can go back to the integral. Do I know what x is? Yeah, u minus 1 over 5. So this is my x, and that's times the square root of what? U and then now I have to figure out, all right, at this point, I need a du in there, don't I? My du here didn't really work too well. Or, it worked out pretty good. But you can even go here and say that dx is equal to, well, if x is equal to u over 5 minus 1/5, dx would be equal to, what's the derivative of u divided by 5? One-fifth times du, which would have been u prime over 5. And what's the derivative of 1/5? Nothing. So that'd be a 0. So now I have something that relates dx to a du. So now I can take dx and say, all right, well, dx is 1/5 du. So I'll put 1/5 du and then multiply the outside by what? By 5. So yeah, this is a little bit weirder. But the idea is, once you take the derivative of u, it isn't what you need, and it's usually in these cases where you have an x times the square root of something. That's the big, honestly, that's the big type of problem that you'll see with this. Now we need to simplify this down. This 5 and this 5 can actually cancel out. So those 5s divide out. What can I do with that 1/5? Bring it out front. So I can take 1/5, and now I have the integral of u minus 1 times, I'm going to say u to the 1/2. Everybody okay with that? And then du. Oh, I didn't integrate anything yet. So you can't put the plus c yet. Now, can I do a distributive property here? Alright, so what's u times u to the half? Yep, u to the 3/2. You add 1 to it, so you're adding 2 over 2 to it. Now, minus 1 times u to the 1/2, so it's minus u to the 1/2. And that's du. Now, can I integrate that? So what would be this one? It's what power would u be raised to? Yep, 5/2 power. So I'm going to divide by 5/2, which means multiply by 2/5. Minus, now I have u to the 1/2. Integrate that, I got to add 1 to it, so it's 2 over 2 plus 1/2. So it'd be u to the 3/2. Now if I divide by 3/2, what am I multiplying by? 2/3. And then that's plus c. I could distribute through with the 1/2, so it'd be 2 over 25. Now, I want to take the u and I want to make it into x's again. 5x plus 1 to the 5/2 minus 2/15, because I distribute again by the 1/5. Then I take the u, which is up here, the 5x plus 1, and then plus c. So this one is a little bit more complicated, and that's because you had an x, the straggling x that was out there, that really kind of threw a wrench into the whole thing. But we do have that equation, u equals 5x plus 1, that relates a u and an x together. So we can get rid of the x's and put it in terms of u at that point. And we can also use that to find the du as well, which if we would have used this here, du is equal to 5 times dx. Well, dx would be equal to 1/5 times du, which is what we figured out over here anyway, wasn't it? Aren't these two things the same? Yeah, it's just kind of looking at it from two different directions. So we found out that it ended up being the same no matter what, so it ended up working out. The biggest trick with this whole thing is this part right here. Here's your trick. That part right there. And this part right here. Because that part is going to go right into there, which takes care of that x, which is right there. So that's the trick in that case. And you'll get better at the trick. The more you do it, the better off you'll get. Yes, sir.